Hi, welcome back to Dr. Matt's Metabolic Kitchen. My name is Jeeva. For my 2024 National History Day project, I got to interview Professor Sam Apple, author of Ravenous. My project was about how Otto Warburg's cancer research was a turning point in history, and I thought this interview might help others too. So, yeah, enjoy.
All right. Once again, thank you so much. I'm very happy that I get to interview you.
Yeah, thank you for having me.
So the first question I wanted to ask was a bit about Warburg's personal background. Otto Warburg was considered the greatest biochemist of the 20th century. Today, we owe a great deal of our understanding of cancer, respiration, and photosynthesis to Warburg. What was his childhood like, and what stood out to you?
Sure. Well, he grew up in the late 19th century Germany, and it was a time when German science was really on the top of the world. It was the premier scientific country, and Warburg's father, Emil Warburg, was one of the preeminent physicists of his era. He actually had a chair at the University of Berlin and was close with Einstein, among many other prominent physicists of the era, Max Planck as well. So Warburg grew up really surrounded by some of the greatest minds, greatest scientific minds in history, and had a very rigorous education and understood himself from a young age as a future scientist. The question in his mind was always only which great discovery he was going to make.
Okay. That kind of segues into my next question. How did Warburg become interested in cancer research?
Sure. There are a lot of different factors that contributed, I think. First and foremost was that Warburg wanted to make a great discovery. He didn't want to be just another scientist, just another medical researcher, chemist. He wanted to do something that would change the world. And that was, partially because his father's influence and growing up with people like Einstein. And question is why cancer? I think it was because cancer was becoming the disease of his era. It was growing increasingly common in many Western countries in the late 19th century and early 20th century. And while Germany was making progress against many other diseases, infectious diseases, cancer was becoming only more and more common. So it was sort of the great challenge of his time, and I might argue of our time as well. It's one disease where we've made such little progress in many respects. So Warburg saw it as the great challenge of his era. He saw himself in a line from Pasteur to Robert Koch and others, and he was next in line, and cancer was going to be his challenge.
Speaking of that, I think the title Ravenous for your book, I thought it was a brilliant choice. But for someone new to the Warburg Effect, how would you explain your reasoning behind the title?
Sure, that's a good question. Ravenous, I think, works as a title because it speaks first and foremost to the biochemical process that Warburg discovered, the Warburg effect, when the cancer cell becomes ravenous for glucose. But I chose the title in part because I thought it worked on an additional level as well, that it could speak to the Nazi history in the book and sort of the Nazi ravenous appetite for, really for land and for dominance. So I thought it worked on two levels. It was not actually my first choice for the title, though. My first choice was A Disease of Civilization, which I thought also worked on multiple levels. But, the publisher had other ideas.
Actually, I think this is perfect because that was actually what I was going to ask about next.
Yeah.
I was going to say you titled the first part of your book "Cancer: Disease of Civilization." Are
Yeah.
you alluding to the modern dietary lifestyle and its connection with cancer, or was there more to that decision?
Yeah, I think that title works on different levels as well. They wouldn't let me call the book A Disease of Civilization, so I used it as a section head. Yeah, that was a term that was used in the 19th century to talk about these diseases that seem to be more common in sort of modern industrial societies. Cancer was one of them, diabetes, obesity, cardiovascular disease. They became known as diseases of civilization, which of course has, it can sound racist today because, civilization is kind of a loaded term, and in the 19th century, they talked about civilized society and uncivilized society. So I certainly didn't want to echo that kind of history, but I thought that it worked as a title nonetheless, because Nazism, in a way, could be also thought of as a disease of civilization, an ideological disease that spread through mind. So that's why I thought it was an interesting title. But the fundamental mystery in my book, I think, that I was trying to solve, and that I think the entire world needs to solve, is why is it that these diseases and cancer, first and foremost, grow more common in these societies? My conclusion is that it's ultimately something about the diet that in the modern Western lifestyle, that remains a somewhat controversial view, but I think that's where the strongest evidence lies. It could be, in theory, it could be something else about modern life in an industrial society, but I think the diet is where the evidence points.
I did think this was definitely a part of Warburg's life and his story that interested me the most. I think it was, why did Warburg's work go into obscurity in the 1950s, the 1960s, and why has it resurged and become prominent again?
Sure. So it went into obscurity in part because, after the war, after World War II, a lot of ideas that were prominent that were associated with German researchers sort of disappeared. And part of it is just the natural sort of pendulum swing of science, where researchers get excited about one idea and then leave the old ideas behind. So once scientists, and beginning with the discovery of the structure of DNA, and then in the following decades, scientists were able to identify specific genes linked to cancer. So it seemed that cancer research had entered a new era of genetics and oncogenes. These genes had been linked to cancer, and all the work that Warburg did on metabolism was considered sort of boring old stuff, not interesting. Had to do with basic biochemistry, but nothing to do with the more sophisticated aspects of cancer. So that was a big part of it. And then there was also the fact that Warburg himself was, not a great spokesman for his own cause. He insulted everybody and, made a lot of enemies. And some people suspected him unfairly of being a Nazi collaborator. So there was lots of reasons. And why it came back ultimately, I think, is because as the research progressed, it was sort of staring the entire cancer world in the face in a very literal sense, because one of the diagnostic techniques that emerged, the PET scan, really simply detects cancer by detecting where in the body more glucose is being taken up. So, that is the most direct evidence of the Warburg effect and its centrality to cancer. So I think that was part of it, but even more so, these researchers who weren't at all interested in Warburg, they were interested in cancer genetics, but they were essentially creating maps inside the cell from one protein to the next, understanding how cancers basically created these dynamic networks in the cell that allowed the cell to grow and multiply. And as they followed these paths, they found that they came right back to these enzymes that Warburg had been interested in, these metabolic enzymes. Caveman, who I talk about, was one of the first. Craig Thompson was another. These scientists, sort of rediscovered these old enzymes that, they had become known as housekeeping enzymes. That was a way of saying they, were part of the cell, but not the key to it. And then sure enough, they found that these metabolic processes were really central to cancer. And what really struck me is that not only were they central, but you could make the case that these enzymes that Warburg studied are the most central part of cancer, because if a cell tries to grow and multiply and it doesn't have these metabolic adaptations that allow it to take up more glucose and other nutrients, then a cancer really can't grow. You can't build a building unless you first have sort of control over all the supplies coming in. That's one of the analogies I use in the book. So that sort of showed all these scientists that metabolism was central to what's going on inside the cancer cell. And then the other element of it is sort of at the meta level, at the whole body level, which is we see that this epidemic of obesity is taking off and is clearly linked to cancer in some way. So that was a sort of a second mystery I was trying to piece together in my book. What is the relationship between the cancer cell overeating glucose and our bodies sort of taking in a lot of nutrients, and can you connect these two phenomena? And I in the last part of my book, I tried to piece all that together with the latest science on insulin in particular.
How do you think Warburg inspired generations of researchers who came after him? For example, Krebs.
Sure. Well, Warburg had a relatively small laboratory in Berlin, but in the 1930s in particular, and then in the early 40s before the Nazis sort of put an end to all that, Warburg's lab was the premier place for the best scientists, the best biochemists, cellular physiologists to come and do research. So he, the people that studied with him went on to great careers in other areas, but Krebs probably first and foremost. Krebs learned how to do all his basic research right by Warburg's side, and then of course was kicked out of Germany by the Nazis and went to England and sort of put together the Krebs cycle, figured out the Krebs cycle using Warburg's manometer and all the tools that Warburg had taught him. So he had enormous influence, in basic biochemistry. And he also, apart from Warburg's cancer research, he just did tremendous work in crystallizing, so many of the key enzymes involved in cellular function. I mean, he won the Nobel Prize for his work on respiration, not on cancer. And he had played a key role in understanding NAD and, really the most fundamental cellular processes he had a hand in, either directly or indirectly through his students.
This last part was what I really, really wanted to hear from you. You wrote that Warburg's biography can be read as the story of a visionary whose ideas about cancer were overlooked for too long. It can also be read as a parable of the dangers of certainty. If Warburg went wrong, where did he go wrong?
Sure. Well, I would argue that he went wrong in a number of different ways. I mean, I would argue that, he ultimately went wrong on an interpersonal level, that, he was arrogant throughout his life, but in the last part of his life, he, became so defensive and self-assured, or I should put this another way. He was very arrogant, but I think on the inside he was, deeply insecure, which is often the case with someone who projects such arrogance. And I think that he also went wrong as a scientist. In the 30s and 40s, he was a very reliable scientist and, truly a genius at the top of his field. And what he discovered about cancer, was never really challenged, that the cancer cell takes up more glucose and that this is central to cancer. What was challenged was Warburg's sort of analysis of why this is happening, his sort of interpretation. He was much more reliable as an experimentalist and as a researcher than as a theoretical scientist. And so Warburg made claims about why the cancer cell makes this shift to aerobic glycolysis and taking up more glucose. And those claims were harder to defend. In his early work, he didn't say that respiration comes to, that aerobic respiration with the mitochondria comes to a complete halt. But in his later years, he started to say that, that the respiration through glycolysis, aerobic glycolysis, is a complete sort of replacement of the breathing that takes place in the mitochondria, or the grana, as Warburg would say. And so he was just making extreme claims that were harder to defend. And it's a shame because I think the core of his thinking was sound. And because he made these extreme claims, it was easier for his enemies and scientific, scientists who didn't necessarily agree with him to challenge his work. But what I do think he gets credit for is he never sort of took his eye off the ball. As all these new genetic discoveries came along, Warburg always very clearly saw that metabolism was at the heart of the story, and he said it over and over again and tried to get the world to listen to him. There's one famous line from his 1956 papers where he talks about, the difference between two types of engines. I don't know if you recall that from my book, but that might be something interesting to include in your project. I mean, for him, he could just see what was fundamentally clear in a way that few other scientists could. And I wish so much that he had made more measured statements in the latter part of his career, because I do think it played a role in his work disappearing. And I do think that the insulin research that I talk about at the end of my book was not something that he could have fully understood because the science wasn't there yet. But I do think he was also ahead of his time in understanding that something about life in the modern Western society is responsible for the metabolic dysfunction. Warburg thought that it was probably all the chemicals in the air or chemicals in food that were poisoning the mitochondria, poisoning respiration, and forcing the cell to sort of turn on this backup engine, which, is a plausible theory, and many smart people continue to think versions of that idea are correct. And there may be some truth to that, but I think he missed the story of sugar and refined carbohydrates driving hyperinsulinemia, in part because it was just, before his time. I mean, it came after his time, I should say.
All right. Thank you so much, Professor Apple.